Okay, this is for differentiation. In H1 Math, there are only 3 types of differentiation question. Your job is to recognize which question is what type when you see it. Observe, the 3 types are animals, tangent normal, and maxima minima. Alright, let's start off with animals. Animals is our cute little way of calling the types of functions that we will differentiate. The animals are these 4 types over here: x to the power of n, e to the power of x, ln x, and fx to the power of n. Anytime you are doing an animals question, you are only doing one of these 4, or a combination of 2 or 3 of these 4. Some questions are cruel and you'll be doing every single animal. All the animals are in this question, and then that looks like a zoo. Okay, so once you recognize differentiation question, oh, it's animals, oh, I just need to ask which type am I doing, right? I hope you know how to do the differentiation for each of these animals. Moving on, the question type, tangent or normal. How do you know you're doing a tangent normal question? They literally tell you to find the equation of tangent or normal. Ta-da, you're doing a tangent or normal question. So here are the steps. Okay, we have a step 1 over here, find dy dx, do your differentiation. That's an animals question. Then you're going to sub x equals to something. This one, the question should have given to you. How would they give it to you? Let's say, for example, they give you find the equation. Okay, let's say, I give an example. Find the equation of the tangent to the curve so and so at x equals to 1. So observe, I have an equation over here, and this is an equation, this is a point. So apply step 1. Step 1 says find dy dx. I will apply dy dx. X squared becomes 2x because power bring down power minus 1. 1 becomes poof, nothing, because there's an x power 0 over there. 0 bring down, immediately everything is 0, cancel. Alright. In step 1 it says sub x equals to something. This something was what was given. In this case it was 1, x equals to 1. Two times 1, 2. Okay, this number is the gradient of the curve at this point. Meaning, if I were to draw the curve and x equals to 1, suppose here, at this particular point here, if I were to measure the rise over the run, which is the gradient equals to 2. How do I know that? Because of this. Right, that is step 1. Step 2 is, if you are finding tangent, let m equals to the answer in your first step. Otherwise, if it's normal, then m is -1 over your answer in the first step. So in this case, they say tangent. So I'll do this. Okay, I'll move on to the next few steps. Okay, these are the steps over here. So we have 3, 4, 5. Step 1 and 2 are done. 3, 4, 5. Okay, y equals to mx plus c. And your m sub the answer you got in 2. Okay, we have m equals to 2, so y equals to mx plus c. Let me write that down. Good. Step 3 is complete. Moving on to step 4. Sub x equals to what? Y equals to what? Now, just one thing to note here. This x equals to what? The same thing as what we had up there. Exactly the same thing. You're gonna ask yourself, what about this y? Where did this y come from? This y value, you can find it by taking your x, substitute it into the original equation. So what do I mean by original equation? This over here is my original equation. So if I sub x equals to 1 into that, I will get the y coordinate. Then I'm able to proceed with step 4. Sub x equals to something, y equals to something into the equation in number 3. So let's do that. Okay, so I have my x coordinate and y coordinate. It's talking about this point over here. So now that I know that here x equals to 1, I get y equals to 2. Sub it into the equation. This one over here. Okay, turns out in this case c equals to 0. Is it always 0? Not always. Just so happens to be. And then finally, in the last step, what does it say? Sub c into 3. So this equation again. Alright, and here I get it. This is the equation of the tangent. If I were to find the equation of the normal, what would change? This step would change. And then everything below, exact same procedure, but just the numbers would change a bit. Maybe your c value is different than the final equation, just slightly different. Okay, so that's tangent and normal. Doing all these steps easily gets you 4 marks, 4% of your paper. That's not bad. Okay, lastly we have maxima, minima. Maxima, minima question. Well, how to tell? See, actually for differentiation, it's very straightforward. If they want tangent normal, they will ask you find the equation of tangent normal. And if they want the maximum or minimum value, they will literally ask you maximum and minimum value. So all is very straightforward. You see the words, trigger. You just get triggered already. Okay, you know you're doing differentiation. You call upon these steps to solve. Okay, here are the steps. Okay, these are the 5 steps here for maximum, minimum. Okay, first thing first, we're going to look at the first 2 steps. Form the objective equation and form the helper equation. Let me give you an example over here. So let's say I'm given a 100-meter wire and I want to bend it into a 4-sided shape. Okay, and suppose it all have right angles, so I want to bend it into a rectangle over here. Okay, and I'm wondering to myself, what shape should I bend such that the area is maximized? Maximize the area. So what do I need to know? Okay, well, there's a length and breadth over here, and I wish to maximize the area. Okay, very good. The objective equation is the thing that you want to maximize. Okay, over here they want to maximize area. Okay, cool. So I'm looking at some equation, A equals to something. Then you think to yourself, well, what's the formula of area? This rectangle, length times breadth. Okay, that's easy. And then you think to yourself, well, what I'm used to seeing is like y equals to 2x, something like this, or plus 1, sure. You know, even if you square the whole thing, yes, I can differentiate this, no problem. This is y and this is x. This is a, so I suppose I can let this be y. Yes, I can do that. But on the other side, L and B, who is x? You know, is this x? Or is this x? Like, if one is x, the other can't be, right? Then we're in trouble. Turns out, this is some other variable, you know. It could be L, it could be B. One of them is x, one of them is another one. We want to get rid of another variable. Meaning, I want it to be A in terms of L, a bunch of L's, or a bunch of B's, whatever. But I don't want both. Okay, I'm like trying to remove some impurities over here. So how may I do so? I have formulated my objective equation. This is my objective equation. Okay, I wish to differentiate this. dy dx just means dA over d something lah, but it has to all be the same, either all L or all B. So you need a helper equation. Somewhere in the question, they should have given you some information that you may use to find the helper equation. The helper equation's role is to help you get rid of one of these variables in the objective equation. How can you identify a helper equation? You look for the question that gives you number. The moment they give you number, helper equation is nearby. They say the wire length is 100 meter. So how can I formulate? Then you think to yourself, if I go and open up this rectangle back to a straight line, 2 length, 2 breadth equals to 100. I can formulate that. Helper equation has been formulated. And you look at this and say, that's no good. I respond to you, okay, let's make one thing the subject. So in this case, let's make L the subject. Okay, call this 1, call this 2. Okay. Very nice. So objective equation and helper equation has been formulated. Nice. Let's move on to the steps. Step 1, step 2 is done. Step 3, we want to sub the helper equation into the objective equation. Okay, let's do that. So step 3. Helper down below, objective up above. Observe, I have A equals to something in terms of B. Isn't this nice? It's beautiful, right? Because now I can let this be my Y and let this be my X. Okay, if I were to write it like this, isn't this a form we are very used to? Is it easy to differentiate? Oh yes, you bet, it's very easy to differentiate. So instead of writing dy dx, I'm going to write, in this case, dA dB. Okay, if ever you get confused, you just take a pencil, write down what is y on the left hand side, then fill in the x on the other hand. Okay, I'm going to differentiate it. This is what you should get. Okay, step 3 has been completed. Let's move on to step 4. We have found our dy dx. They say let it equals to 0 and then solve for this so-called x. And again, I remind myself that x is the b, right? It's my x. So, okay. Solving. Okay, b equals to 5. This is my x. Remember, this is my x again. I have solved for my so-called x. Okay, so step 4 has been completed. Right, moving on to step 5. Verify that it is a maximum or minimum. How do you do this? Well, we're going to draw the table. Okay, typically how you draw the table is something like this. Alright, you're gonna draw a table exactly like this. Now what you want is this one to be the stationary point, your answer, so to speak. In this case, we got 25. 25 should go here. Okay, so add a little bit. Up to you. You can be 26, 27. In this case, my little bit is 0.1, 25.1. So that's plus a little bit. This is minus a little bit. So 24.9. Okay, what you're gonna do is you're gonna take a calculator, and you know your dy dx, right? In this case, our dy dx, so-called, was this equation over here. Right, that was our equation. So I'll take my GC, substitute 25, 24.9, and 25.1. So let us do that. Now for those of you wondering what am I doing, this is just a GC app, simulates your GC. So what I type here, you can type in your own GC. This is a life hack method to do multiple substitution at once. If you can catch it, then good for you. If you can't, that's fine, or you can figure it out on your own. Okay, I've asked the GC to substitute 3 values for me. The 3 values specified 24.9, 25, and 25.1. I substituted into my dA over dB, my so-called dy dx function, and I gotten these 3 answers, 0.2 and 0 and negative 0.2. I don't really care what's the value, I only care whether they're positive, 0 or negative. So it turns out positive, 0, negative. Okay, in this order. Okay, and then we draw. If it's positive, it's going up. You don't have to draw arrow, you can just draw straight line. 0 is straight, and then negative is going down. What does this look like? What does this curve look like? Oh, it looks like a maximum point. Oh, okay. So okay. Usually this is your x. When x is this value, your y is either minimum or maximum or inflex. Okay, so like this, maximum. Like this, minimum. Like this, or like this, we have inflex. Okay, all these steps, easily 5 marks. So step 1 to step 5. I hope this example demonstrates for you the types of differentiation question. Hope you're able to do them. Okay, the task will be linked in the worksheet below. Okay, submit to me and let me know how it goes.